There's another problem from the Larsen 8.9 worksheet, and this is number 12. And again, we have our function f of x equals 4 over 3x plus 2, and we want our center to be c equals 2. So what we want to do is we want to, first of all, put the 2 in front so we can start to get it to look more like this form, so we can use a geometric series to derive our series that we're going to work with, because it does look like it can be put in that form. And so we've got the 2, and we've got plus 3x, and we want to have the center to be c, so eventually we're going to try to get x minus 2. I've got a 3 in front of the x, so 3 times 2 is 6, so I'm going to have to put a 6 here, so when I factor the 3 out, I'll get a 6. But if I subtract 6, I have to add 6. So we do this little technique here of adding and subtracting the same number, so we're just adding 0 to the denominator. It's not going to change anything, but it sets it up so when we can divide out, and again, whatever's in front of the x, if you multiply that times the center, that's going to give you a hint of what you need to add. When we factor out, we're going to end up with 3 times x minus 2, and then 2 plus 6 is 8. So we have 4 over 8 and 3 times x minus 2. Now again, to be in this form, we need to have a 1 here, so we need to get rid of make the 8 1, so we have to divide by 8. So divide everything by 8. Top by 8, first term of the bottom by 8, second term of the bottom by 8. In other words, every term in the numerator and the denominator you have to divide by the same number. 4 over 8 is 1/2, 8 over 8 is 1, that's what I want. And then I want this to be minus x, or minus r, excuse me. So make this negative and negative, that's going to make this positive, breaks up into 2 negatives. And 3 over 8, x minus 2, and this is my r, and there's my a. So there's my a, and there's my r. Now we can find the radius of convergence just by making sure that, well, just finding what values of x will make the r, the absolute value of r, between less than 1, which means r is between negative 1 and positive 1. Doesn't matter on this negative side, because when we take the absolute value, that's going to go away anyway. It's going to become positive. So this is what we have. Then I can multiply both sides by 8/3, or multiply all 3 parts by 8/3, and that will make this just x minus 2, and then negative 8/3 and positive 8/3. Then if I add 2 to both sides, 2 is 6/3, so 6/3 plus 8/3 is 14/3. 8/3 minus 6/3 is 2/3. Negative 8/3 plus 2/3 is negative 2/3, and there you have your radius of convergence, negative 2/3 and 14/3. So that all makes sense. So let's get back over here and deal with our series. So once we have it in this, once we know it's a geometric series, we know that that's going to be the sum from n equals 0 to infinity of a to the r, a times r to the n. So there's my a is 1/2, and this is my r to the n. And we can take the 1/2 in front because it's not raised to any powers, and then we can break this up, negative to the n, so we're going to have negative 3 to the n, and then x minus 2 to the n all over 8 to the n. You could always make this 3 to the n, and then you could make this negative 1 to the n also. There's all kinds of ways you can do it, but this is satisfactory. Okay, so take a look at that. I hope that makes sense. And once you get the hang of it, like I said before, these aren't too bad.